All right, so let's go ahead and talk about domain range. Let's continue to work with quadratic functions and investigate these. But now we're going to really compare and contrast the two different forms that we can write these quadratic functions in. So again, the equation of a parabola can be represented in either vertex form or standard form. So if I have vertex form, I can easily identify the vertex. I can find H and K easily. And I can find the vertex, and then I can choose some x values to the left and to the right so that I can evaluate the function at those points. And then I could graph it. I could tell you the axis of symmetry. I could tell you the domain and range. We're going to continue to do that. But what if I give you the equation in standard form? I don't see an H and a K, but I can easily find the vertex. The vertex is, well, for the x value for H, it's going to be negative b over 2a. So that's how I'm going to find my H. To find my K, well, once I have my H, my negative b over 2a, I'm just going to evaluate the function at that x value. So again, to find the vertex of a quadratic equation written in standard form, I need to identify b, and I need to identify a. Yes. Then I evaluate negative b over 2a. That's going to give me the x. Then once I have that x, I substitute back into the original equation, and I find y. There's your vertex. Then we continue on like we were, doing things like we were doing last time. So, again, how do you know if the parabola is oriented upward? What do we look at? What are we looking at in the equation, no matter what form it's given to us in? A. If A is positive, it opens up. If A is negative, it opens down. Right? HK is our vertex. We can find it whether it is in vertex form or whether it is in standard form. We can also write the axis of symmetry because all we need to know is the x value of the vertex. Josh. Yes, instead of taking the square of x minus h, you take the absolute value of x minus h. Yes, it is, and I love that you see the relationship. Okay, so let's go ahead and look at a few examples. We are going to be given an equation, and we're not going to do every example in this because, they're practice. But if I am given this equation, first you have to recognize that it has been given to you in standard form. So perhaps we want to immediately identify A, B, and C. So what is A? B and C, 5. Once I know that, I can find my vertex. I can find the x value of my vertex. So I'm going to write that as x subscript v to say that's the x value of the vertex. All I have to do is evaluate negative b over 2a. So that is negative b over 2a. So that's 6 over 2, which is 3. So I now have the x value of my vertex. How do I find the y value of my vertex? I evaluate the function at the x value. So I'm evaluating the function when x is 3. So that's 3 squared minus 6 times 3 plus 5, which is what? Negative 4. I now have my vertex. Now, keeping in mind that my vertex is the h value and the k value, can you tell me the axis of symmetry? And you always write it as a line. This is a line of symmetry. It's an axis of symmetry. Do not just give me 3. Beautiful. And again, I know that because x equals the h in the vertex, the x value. Now, if I wanted to ask you what the domain is, well, there's no work to be done because this is just all real numbers. Always for a quadratic function. Now, we will have quadratic equations. If I ask for interval form, then I need an interval. If I don't specify, I don't care how you represent it. Good question. Again, for quadratic functions, all real numbers, there are quadratic equations that open to the left or to the right. The y term is squared. It's not a function. So that's a different story, right? We're talking about quadratic functions. Okay, now keeping in mind, I want to know the range, but sometimes if you want to do a quick little sketch, I know that's my vertex and it opens up or down? Up, right? Because A is positive. So I could do this and that might help you see the range. What is the range? Yes. So here it is as an interval. And here it is using inequalities. And we should be able to write each, right? Okay. This is an exercise, you know, we're not doing it. It's just like the one we just did. I will practice it, make sure you can get it. Another thing that you can do, like we were doing before, is we can create a table of values. In the last example that we did yesterday, I gave you the x values. Well, so that I can actually see the U shape and see the vertex, maybe the first thing you want to do is calculate the vertex. Soon as you know the vertex, then I personally would put that here for that x value, choose one to the left, one to the right. You know symmetry. You have it, okay? So this is no difference. The only difference with this example is that I'm not giving you the x value. To find the right x values, you want to make sure that you identify the vertex first. Does that make sense? Okay. We're going to skip that one too because there's no difference. The only difference is now you have to figure out the x values. I would still do these on your own to make sure you can get them. Now, looking at the next example, here is a good example of what would be on the test. Let's go straight from start to finish on this one. Okay, so it's in standard form. Can you tell me, does it open upward or downward? And how do you know it opens up? A is positive. Okay, so I personally would just remind myself that my graph at the end of the problem should look like that. Now, how on earth would I find the axis of symmetry? What would I have to do first? I would find the vertex, right? Exactly. So to find the axis of symmetry, I need the x value of the vertex, negative b over 2a. Now, I know a is 2. What is b? Okay, so then I have negative b over 2a. So what is the x value of the vertex? One. So what is my axis of symmetry? So I'm labeling it on the graph because we're being asked to graph it. Don't forget to label your axes. Okay, so I know the x value of the vertex. All I have left is to find the y value of the vertex. So all I have to do is substitute 1 in for the function. What do I have? I have 2 minus 4 plus 5, which is So do I have my vertex? You better believe it. It is 1, 3. There it is. Now, y-intercept. That's a critical value. That's important to know. How am I going to find my y-intercept? To find my y-intercept? For any point on the y-axis, x is equal to 0, right? So I'm evaluating f at 0. Okay, so what is f at 0? It's just c, right? So the y-intercept, if I'm asking you for the y-intercept, your answer would be the point, right? Now, knowing what I know about symmetry of the parabola, do I know another point? What's my other point I know? I have enough to graph my beautiful little parabola. Right? Because I know about symmetry. So I have, yes, sir, Josh. Go ahead, no.
Will we be asked to, if something's in standard form or vertex form, convert it to the other?
Yes. We'll do something like that. Mm-hmm.
Wait, how did you get the 205 points?
I know along my axis of symmetry, if I fold it, I get a mirror image. So if I know a point to the left of the vertex, I know a point to the right of the vertex. Yes. Yes. Do you see this? This is not beautiful. If you give me this, oops. If you give me this, it's an absolute value function, I will not give you credit. If you give me this, just make sure that, don't give me this. That's not a function, right? That doesn't pass the vertical line test. But, it doesn't have to be perfect. I don't want to see a V. I don't want to see something that doesn't look like a function. I do want it rounded and, like it's going out. But, how picky I'm going to be, if you're slapping like this, I'm going to say it's not a horseshoe, right? Horseshoe. Isn't that what it's called? Horseshoe? Yeah. Okay. All right. I'm not going to do the next one because it's just another example. So you can practice that. The key is, I'm not going to necessarily give you these steps, right? I'm just going to specifically say, does it open up or down? What is the axis of symmetry? What is the vertex? What is the y-intercept? Graph it. I may ask domain range. I may ask for x-intercepts. So if the function has a leading coefficient that is positive, so a is positive, we said that the parabola opens what? Upward. So if it opens upward, and I know my axis of symmetry passes through my vertex as well, then I also know that my vertex is a minimum. And its minimum occurs at the vertex. Now, I want to point out that the minimum, when you're describing the minimum of a function like we've done in the past, it's always the y value, right? What is the lowest y value? That's helping you with the range, right? If the leading coefficient is negative, we know it opens down, so we know the vertex is a maximum. Again, it's the highest y value. Think range. Remember, when we're writing intervals, the first value is the smallest value in the interval. The second is the largest value. So let's go ahead and go through this example. We can do this example. Determine whether the function has a minimum or a maximum value. What are you looking at? The leading coefficient. What is A? A is -3, which is negative. So it opens down. So the function has a maximum value. So now I need to find the maximum value. So the first thing I want to do is I need to find the vertex. So the x value of the vertex is -b over 2a. What is b? B is 2. So -2 over 2 times a. So what is the x value of the vertex? 1/3. So I know my axis of symmetry, don't I? It's not asking you that, but you know, you should think that. So now let's find the y value of the vertex. So I'm evaluating my function, my given function at that x value of the vertex. Don't be afraid of fractions. And what is my y value of the vertex? Got to get a common denominator. Tell me what you get. Josh, are we finding it? What is it? Give me a fraction. I don't agree with you. Anybody get anything else?
-11/3.
-11/3. Okay, so make sure you can get that. So I do have my vertex, right? My vertex is that x and y value. So 1/3 and -11/3. Yes, for graphing purposes, Josh, you would want to convert it to a mixed number to help you. Here's my vertex. If I'm asking for the maximum value, it is the y value of the vertex. So this is my maximum.
But if you find a negative, will also be the-
Yeah, it's always the y value. It's always the y value. Okay? So let's go ahead and do the next one. Is it going to have a max or a min? Okay, so A is 1, which is positive, so it opens up, so I'm going to have a min, right? So I need to find the vertex. So B is -6, the x value of the vertex, -b over 2a. Is what? 3. Good, that's exciting. I'm not asked for the vertex. I need the y value of the vertex to find the min. So evaluate the function at 3, and what do I get? So I do have my vertex at 3, -6, but my minimum value is what?
-6.
Okay. What is my domain? What is my range? Right? Those are fun. Okay, now we talked about finding solutions to quadratic equations. These are zeros. So the zeros are the values of the input x that make the output 0. Yes.
That's why we put it equals.
That's exactly right. That is exactly right, Josh. So the zeros of the function are the roots. They are the solutions for when the output is 0. And they also allow us to find the x-intercepts because they are the x values for when y is 0. Now, we calculated the discriminant and we said, hey, I could tell you if they're two real, one real repeated, or two complex solutions. But how would I be able to see that on a graph? Well, if you have a parabola graphed in the Cartesian plane, it can be positioned, well, infinitely many ways, but with respect to the solutions representing either two real solutions, one real solution, or no real solutions. And if I have no real solutions, I have imaginary, or I should say complex solutions. Good. So if the question asks you how many real solutions, or find the real solutions, and you calculate the discriminant as negative, you can immediately tell me there are no real solutions. There are none. None. So that's a little shortcut, right? So if I have two real solutions, I have two x-intercepts. The graph is going to cross the x-axis two distinct times. And so I would know what about the discriminant? It's positive, okay? If I have one unique real solution, it is a repeated root, and you will recognize that on the graph because it touches the x-axis. It doesn't pass cleanly through it. It touches and then changes direction. And how would I recognize that in the discriminant? Good. And if I have no real solutions, it is never going to cross the x-axis. It changes direction off the x-axis. So you technically have two complex solutions. However, we are looking at this graph on the real coordinate system, not the Argand plane, also known as the Gauss plane. Then we have complex solutions, and how would I recognize that in the discriminant? Discriminant is negative, right? So here we have no real solutions, but we do have two complex solutions, and they are conjugate pairs. Okay? So let's look at the next example. Again, I'm not going to give you all these little clues here. You're just going to have to provide me with information. Does this open up or down? It is going to open down. And how do I know that? Because A is less than 0. In this case, it's -1. What is B? -2. That's nice. And C? Yeah, all right. And so what was the y-intercept? It's a point, right? Oh, why did I write 8? 3. Okay, can we find the vertex? Of course we can. The x value of the vertex is? What is it? -1. Y value of the vertex is the function evaluated at -1, which is? Was that a question or an answer? Okay, so there's my vertex. So I can go to -1, 4. There's my vertex. My y-intercept we said was at 0, 3. We said it opens down. It makes sense. I know another point because of symmetry. What's the other point that I know? -2, 3. So there's my vertex. It's hideous, but you know, it's all right. Do I know my axis is symmetry? What is it? X equal, yes.
For the axis of symmetry, is it always a dotted line?
Yeah, because it's not really the part of the graph, right?
It's not a real line.
Yeah, it's the graph is just the parabola, the U shape. Now, what if I wanted to know the x-intercepts? Can you find the x-intercepts? How? Okay, so you're telling me set f of x equal to 0. Okay, you want to factor it? Is it factorable? Tell me my two x values that would make my y value 0. What are my x-intercepts? Find me my solutions.
3 and -1.
Okay, so my x-intercepts are so my x-intercepts are -3, 0, and 1, 0, right? So I had this, and then I have this and this. So those are your critical values. Critical values are vertex, y-intercept, x-intercepts, axis of symmetry. So I'd want to see all of that. Fair? Yes.
Doesn't really look factorable. The 3 is positive.
Multiply the whole thing by -1,
Yeah.
right? So oops, I should say, if I want to see when it's 0, I could divide everything by -1. And look at that, that's beautiful. That's beautiful. That's beautiful. Right? All right, now, let's say you had a calculator, you won't, but let's say you did. And you wanted to see where the parabola, what the solutions were, what the x-intercepts were, what the max was, what the min was. Can we do that? Of course we can. Can I just show you ever so quickly? Yes. Oh my goodness. How am I gonna do that here?
You can go to decimal.
No, I need to use I want to use the calculator because this is gonna lead us to quadratic regressions and stuff. So we have to be able to use the calculator. So let's pull this up. And then I will share that screen instead for those of us who are not in the room. Those of you online, are you seeing this?
It's just showing an icon. I can't really see anything, but
You can't see anything.
no.
Can you see it now?
Yes.
I can see.
Okay, so I'm gonna put this function in there. I'm gonna go to y equals, of course I'm gonna clear everything else. Then I'm gonna go to y equals and I'm gonna put in negative, and make sure you use the negative sign, x squared minus, it's a minus sign, minus 2x plus 3. Okay, now there it is. I'm gonna graph it. Oh, it looks like our graph. So if I were to go to the table, second graph is your table, what am I looking for to find the solutions? When x equals 0. So if I look at this, when I have y is 0, this is my x value that is a solution. Y is 0, this is my x value that is a solution. So I know my x-intercepts, right? Now, is there a way for the calculator to tell you the vertex? Of course there is. I'm going to go to stat. I'm going to scroll to hold on. No. Second trace. I was already doing regressions. We're not there yet. Go to second trace, which is calculate. And for this particular parabola that is oriented downward, does it have a max or a min? A max. So if I want to find the max, it's going to tell me go to the left of the vertex. It's asking for a left bound. It wants a window to look in. There it is. Then it's saying, well, all right, go to the right of the vertex. It doesn't matter where, just somewhere to the right. And then hit the right bound, and you're telling the calculator to look in here for the max. There it is. Right? -1,4. We got that. Yes? Now, it will also allow you to find the zeros. It will again ask you for the left bound, but you could go to the table and find that as well, right? So the calculator can do all this stuff for you. Ah, there it is, right? That's exciting. Okay, let's go back to our notes. Let me go back here and share here again. You will have your calculator on the test only to do a quadratic regression. You will not have your calculator for the rest because you'll have to be able to do everything by hand. Okay, so are we here? Are we back to our notes? No. Yeah. Yay. Okay. All right. So what do we have now? We talked about what to look for in the table of values. To find our intercepts, it's when y is 0, right? And we can also find the max and the min. Now, with a line, you needed 2 points to plot a line, to graph a line. How many points do you need for a parabola? Just 3 non-collinear points are needed to graph a parabola. So if I were to give you x1 equals -2, x2 equals 4, such that -2, 0, and 4, 0 are my intercepts, if I ask you to find the quadratic equation of the parabola that passes through that, I can work backwards. X equals -2, x equals 4, right? Those are two solutions. So what would be the corresponding factors? Excellent. And then if I wanted to write the equation in standard form, what would I do next? I would just FOIL. And what is the equation? +8 -8. So if I were to give you solutions, you should be able to work backwards to get me the equation. Okay? Now, we did the exploration. We talked about the transformations that are made to the parent function, how they resemble the absolute value function. On the test, I may give you the equation and then you have to describe the transformation. Or I may give you the transformations in words and you have to write the equation. So let's talk about how to do that. If you are given this equation, what form is it given to you in? Vertex form. So if it's given in vertex form, can you tell me what the vertex is? Do you agree with that? It's 2, 4, right? H is 2, K is 4. If H is 2, what transformation is that implying? Yes. And since K is 4, that implies what? Yeah. So if I know my parent function, which you should really be able to graph ever so quickly, if I wanted to graph the transformation, the image function, I would just take my vertex and every point and shift it to the right 2 and up 4. So my vertex is now here. This point goes to the right 2, 1, 2, 3, and up 4. This point goes to the right 2 and up 4. Are you with me? This goes to the right 2 and up 4. Do you see how I can get my image function ever so quickly by just performing the transformations? So there's really not much work to do if you can recognize the transformations. Let's try another one. This is in vertex form. What is H? Be careful. H is -2, right? Because it's x minus h. So h is -2. So what is that transformation? A shift, left 2. And then k is -3. So that's a shift down 3. So again, I start with my parent. And I shift to the left 2 and down 3. To the left 2, down 3. To the left 2, down 3. See how quick and easy it is if you can recognize the transformations to graph it? Now you could FOIL this, subtract 3 and get it in standard form, and then go through that and -b/2a. This is easier. Okay, the last thing that I want to talk about today is what if I give you the words, can we write the equation? So we start with the parent, and we apply h and k and a. So if I am shifted 2 units to the left, what is that? H, K, what is it? H is -2, okay? And if I go 5 units down, then I know K is -5. So can I write the equation of the image function? Yes, and notice how I said it is g of x. So g of x is x, what? X plus 2 squared minus 5. Okay, what about the next one? The next one says 2 units to the right, so that means h is 2. 4 units down, so that means k is -4. I want to write the equation of the image function g of x in vertex form, so that would be x minus 2 quantity squared minus 4. Okay, what about the next one? We have a vertical stretch by a factor of 4. So what is that telling me? A equals 4. I'm reflected. Reflected across the x-axis, so A is negative. So what is the equation? -4. Fair? Okay, now this is just practice for you. This is practice as well. We will talk about applications next time. Okay, so we will start with applications. I'm sorry? No, because it's not that hard. It's just, is it positive? Is it negative? Is it zero? How many solutions is it? I did not change that. All right, you've got 20 minutes. You can finish that discriminant homework. Are there any questions online?